Yes, madunggan ba ko class? Okay, am I audible?
Morning, ma'am. Yes po.
Thank you. So, if you remember, using portal method, our assumption is that there is a shear at each column and double shear for the interior and then single shear exterior. That is for our portal method. When it comes to cantilever, lahi po yung concept. So the cantilever method is based on the same action as a long cantilevered beam subjected to transverse load. So, nakakibalik. It may be recalled from mechanics of materials or mechanics of deformable bodies that such a loading causes a bending stress in the beam that varies linearly from the beam's neutral axis. So, ingani examples naka-vertical lang ni sa class pero kung ato ni siyang i-incline our beam ang kamaw siya. So, naatay force release. So, once the force is applied, naaman tayo mga reinforcement sa sulod. Ang behavior man sa is pag tensile ang ubos at tensile ang taas, compression ginibuhas. No? Kaya ang bending man ana. Bending. So, muling iyang behavior at the neutral axis, mabira sa paggawas. Kung ang action sa taas is mabira, galing sa ubos is yun is makompress yun. Nga naman na sa atong beam. It's tension ang taas, compression din ang ubos. Kung ano na sila, counteract. So same, in a similar manner, the lateral loads on a frame tend to tip the frame over or causes a rotation of the frame at about a neutral axis lying in a horizontal plane. Lying in a horizontal frame that passes through the column beams on each portion. So, pag-abot naman sa atong frame, same concept gihapon. But the changes for the reaction niya is really mo occur sa columns. So, to counteract the tipping, the axial forces in the columns will be tensile on one side of the neutral axis and compressive side on the other side. So, ingani ang concept sa ating cantilever. Naay lateral load na na-apply and ang iyahang reactions at the bottom, you will identify the neutral axis. On the other side, tension. On the other side, compression. So, muna ang concept for our cantilever method. So, the cantilever method is therefore appropriate if frame is tall and slender or the columns has different cross-sectional area. So, diyan na ito ma-apply ang atong cantilever method. So, using the cantilever method, the following assumption also is applied if you will analyze a fixed supported frame. So, iyang support is ka-fixed class ha. So, if you remember, on the portal method na ay tulo ka assumption. Nagyapon tayo tulo ka assumption. So, the first, kaning number 1 and number 2 is the same for cantilever and portal. So, a hinge is placed at the center of the girder or beam. Since this is assumed to be a 0.0 moment, and the second assumption is that a hinge is placed at the center of the column. So, same sila ang first and second assumption. Ay kung portal, nagbutang man taog hinge sa beam and column. Same gyapon sa cantilever. Kanira ang assumption number 3 ang nalahi. The actual stress, no. Okay. If you remember, using portal method, the third assumption is on the shear stress. Now, shear stress ang basis. When it comes to cantilever, it's the axial. Axial stress, it means vertical loads. So, the actual stress in a column is proportional to its distance from the centroid of the cross-sectional areas of the columns at a given floor level. So, actual stress, but remember class, in a column gyapon. Sa column gyapon yung actual stress atong basis. So, it is proportional to the distance from the centroid. So, you need to identify your distance from the centroid. Ay maka-formulate of equation that is proportional to the column. And at a given floor level, so the analysis is every floor level. Since stress equals force per area, then in special case of the columns having equal cross-sectional area, the force in a column is also proportional to its distance from the centroid of the column area. Kung same ang area sa columns tanan, so dito na ta mo diretso sa equation nga proportional si distance from the centroid. It comes to its column area. Pero kung lahi gap or lahi gani iyang area, we should consider the cross-sectional areas for each column. So these three assumptions reduce the frame to one that is both stable and statically determinate. So, tulog ka pa ito assumption dito class ha. So, let's go to examples. So, determine approximately the reactions at the base of the columns of the frame shown in the figure. The columns are assumed to have equal cross-sectional areas. So, equal in cross-sectional areas class. Use the cantilever method of analysis. So, unsa kanito atong first assumption? We will put hinges at the center of its girders or beams. And magbutang po taong hinges sa midpoint sa imong column at the given floor. So, so after that, you will solve the centroid of the column's cross-sectional area. So, kung equal ang cross-sectional area class, pwede na nimo na siya butang 1. So, the equation for the centroid is this one. X bar is equals to the summation of x per column, the distance not per column, multiplied by A is the cross-sectional area over the summation of cross-sectional area. Muna ito equation. So, kuhaon na itong neutral centroid saan ni na itong frame. Now, question, ma'am, kanang the value of the centroid, ma'am, is center to center ba sa atong beam? Dili ba pwede nga i-divide na lang nako? I-divide na lang nako ang distance sa beam by 2? Kay 3 mo gyapon ang answer, ma'am. Dili na siya nga mo center sa beam. Example, kung ang given yung distance, ma'am, is kanang 10 meters. Dili ba nako buhaton nga ang iyahang centroid is 5 meters diretso, ako lang i-divide by 2? Dili, class, kay it is the centroid when it comes related to the column's cross-sectional areas. Okay lang ni, ang mugawas is half if your cross-sectional areas are equal. No? Yung cross-sectional areas are equal, most probably ang mugawas is distance over 2 sa inyong beam. But if your cross-sectional areas are different, di na siya located at the center of your beam. So you need to solve. Okay? So x bar is the summation of x multiplied by the cross-sectional area over the summation of area. So start ka, ani, kasara ka mo kuha og centroid. Sa general na siya kay same na siya cross-sectional paubos. No? So start 0. So kani siya ang column. Dili mo tahong start sa left. So 0 multiplied by 8. So pwede rin mo na siya utangan og 1 na cross-sectional area. And then the distance sa second column is 6 meters. So plus 6 multiplied by the area nga 1. Alright? And then summation of area. So area plus area nga equal. So that is 2a. So ang mong gawas sa imo is 6. Ay, 6. Ang mong gawas is 3 meters. So that is the distance from the centroid. So inganin na dahil siya. So after you get the centroid, so you will cut section from the top floor and some of the moments about the neutral axis. So ang plus star sa atong cantilever method class is different. So, di ba, ang portal, ang portal is na IV, na I2V. Ibutang ni mo na directly. Kaya mo man ang concept sa portal. Pagabot sa cantilever, lahi. Dili ka mag-start sa imong neutral axis. No? Sa imong, centroid ni mo. Sa neutral axis lagi. On the left side, so that will be tension. Left side on the neutral axis is tension. Right side on the neutral axis is compression. When it comes to the axial stress. Kana imo assumption dito. Opposite yun na sila pikas-pikas. No? After you identify your neutral axis. Pwede po na siya. Example, kung tulo ka column, and then imong neutral axis na adire, may gigawas. No? X bar ni mo. So, dire, immediately dire is tension, kikas is compressor. Okay? Muna ang concept for our cantilever beam. Cantilever method. And sa portal method is kailangan nato ni una ma-identify si V. Ay hata mo hatog FBD for the forces at its hinges. No? FBD. Waon si V. Dili sa cantilever, ang unang kuhaon Ang unang kuhaon class is kani sila. Kaning axial stress, si tension and compression. Nag-opposite. Muna dapat ang unang kuhaon na to. Aya na yung kamukating. Ibali, ano na din sila. Dito na rin masolve if you do cutting of sections and cutting by hinges. So, unsaon pag pangita sa HY and HK. So, dili ka mo moment class at the neutral axis. You will sum up moment at the neutral axis. So, kani, si CA. So, negative 30 multiplied by 2. So, kani siya. Plus HY, yung moment arm 3 meters. Plus 3K because KY and 3 meters ang moment arm is equals to 0. Now, duha ang unknown, but we can apply the principle of ratio and proportion of proportionate triangle. So, imong tan-awon, they are similar triangles. So, they are equal. So, HY and HK are equal. That means HY and HK, HY and KY is equals to 10 kilos. So, balihan naman mo ni siya. Himuon mo ni KY, either himuon mo ni HY. Yung makuha dayon is 6 HY. So, 60 divide 60 divide 6 is 10. So, HY and KY is equal. So, na kay value have 10 kilonewton for HY and KY. Yan, duha man ni ka-story, kailangan niya po nimo ma-identify ang GY and LY. Same concept class will be applied. Same concept will be applied at the lower floor. Pero, same sa portal gyapon nga mo, accumulate na nimo ang lateral forces sa taas. No, kung makuha ka og GY and LY. Okay? Maoray kalainan sa imong portal. Sa imong portal, imong gamiton nga value is your shear stress. Pagabot sa cantilever, imong gamiton is imong axial stress and tension compression at sa opposite. Gikan sa neutral axis. So, same process, you will do summation of moment at the neutral axis. And the principle of similar triangle, GY is equals to LY. So, your GY and your LY is 35 kilonewton. Mo lang yung identify. After you identify this axial stresses sa kada column, aya na din ka mukating sa section. And the process diha is just the equations of equilibrium 3. So, ang given na dayon is kaning axial o kaning lateral. Okay, mo man imong nakuha. And on the lower floor is also your lateral, your axial stress. Until you reach the bottom, makuha nimo ang reaction. So, labay-labay na siya sa forces. And the moment diagram per floor is this one. So, more siya for cantilever method. Any question? Any question, class? 1.0. Lesser ka sa 10. Lesser ka sa 10. Hindi lesser. Wala? Lesser ka sa 10. Any question? So, let's proceed to example number 2. So, kaning example number 2, show how to determine the reactions at the base of the column. The columns have cross-sectional areas. So, use the cantilever method of analysis. So, kung inyong tan-awon, they have different cross-sectional areas. Two-story atong frame, but that means lahi-lahi ang size sa columns diha. So, kani. The cross-sectional area for the first column is 10 inches, 8 inches the second, 6 inches the third, and inches the fourth. So same process happen. First is you will place hinges at the center of the beams and the columns. Naakay hinges diha. Tangkag hinge. And the second is you will solve the centroid. You will solve the centroid of the column's cross-sectional area. Now, they have different cross-sectional areas, so you will not put one on the area. Imong isulod ang area nga ba siya. So, ano siya? First is the first column, 0 yung distance. 0 yung distance. Iyahang cross-sectional area is 10 plus summation nun, so we'll add distance is 20 feet, kani 20 multiplied by the 8 ng cross-sectional area plus 35. So from the left man, so 20 plus 15 is 35 multiplied by 6 na cross-sectional area, and then 60, which is 20 plus 15 plus 25 multiplied by the 10 na cross-sectional area over the summation of all cross-sectional areas. Okay? So your X bar is 28.53. So as you can see, dili siya located at the center. No, dili siya located at the center sa imong beam. So that is 28.53 feet to the left. From the left. If you draw, locate nimo ang centroid. The left side will be tension, and the right side will be compression. And then minus na rin mo pilay distance diha. Okay, 28.53 man eh. And then there is 20 feet. So immediately this is 8.53. And so on. Minus nimo na. So these are our centroid. Now, atong third step is to solve this. Isolve na to si LY, MY, NY, and si OY. And different man iyong cross-sectional area. So the columns of different cross-sectional areas, so we must consider the actual stress in each column to be proportional to its distance from the neutral axis. So, pag-solve is, atong gamiton is ang stress, no? Gusto siya stress L, stress M, stress N, and stress O. Located at the X bar, so proportion siya sa atong neutral axis. So, we can relate the column stresses by proportional triangles. Ingani, sa ka-triangle, triangle. And they are proportional triangle. Okay? How to solve tungod ang unknown man ana is upat. No, unknown ana is upat. You will make it in terms of one variable. Diri, so si ly ang nasa corner, isolve na to si my and si ny and si oy in terms of ly. How to get that is using proportional triangle and kaning actual stress in each column is proportional to the distance from the neutral axis. So the stress M is 8.53 feet, which is kani 8.53 over 28.53 stress L. Muna itong equation. For N naman, that is 6.47 over 28.53 stress L. Slide proportion. Imo yapon ang balihon sa English. Ano man yapon na siya? Balihon ang triangle. Proportional yapon na siya. And for the stress O is kaniman atong dako ang triangle si O. Padulong mo na siya. Neutral axis to the corner is 31.47 feet over 28.53 feet. So, imo i-substitute ang equation. Stress is force over area. So, my over 8 inches na cross-sectional area. Asa makuha na given over is equals to the distance and ly, ang stress ly, ang equation is ly over the area, which is 10 inches squared. Your my now is 0.3239 ly. So on, substitute ny over 6 inches squared, which is kani in your cross-sectional area, is equals to the distance ly over 10 inches squared. Your my is 0.136 ly. So oy, your cross-sectional area is 10 inches. We substitute distance and then ly over 10 inches squared. Your oy is 1.103 ly. So you have the values of your forces in terms of ly. Muna dahil imo ibutang diri para ang imong unknown variable is sara. And then you will do summation of moment at the neutral axis. Neutral axis, lilimtan ang lateral. So it gives 6 feet ly, 28.53, 0.239 ly, 8.53 feet, plus 0.136 ly, 6.47 feet, plus 1.103 ly, multiplied by the moment arm is equals to 0. You will get this ly value, and imo lang na i-substitute si ly sa aling na equation para makuha nimo si my, ny, and oy. Okay? And sa first floor pa man sa first half pa man to story mo na itong building, kuwaas ano sa side na. So, here. Na? Kuwaon dapat yung si EY, FY, GY, and HY. Ma'am, unsaon, same process ra ani. Same process ra ani because they are similar. And they have same cross-sectional area. They have same cross-sectional area, and then same liya po na sila distance. Ang mag-change na dayon is the value for your moment. Kay, duha naman kag lateral forces. You have the 8 and the 10. Imo ni i-add. So, lahi ang nagawas nga answer. But the equations, kung i-check is parihara. Okay? So, after nimo makuha ang mga actual stresses, di lang gid nimo limtan class na from the neutral axis, on the right side is tension, on the left side is tension, on the right side is compression. Opposite gid sila. Alright? So, pag makuha nimo ni sila nga mga forces at each floor level, ay na dayon ka mukati per hinges. So, ano na din ka, then maglabay-labay na din ka of forces until you reach the reaction. So, dili nga problem is isa rin ipakita because nakita naman na ninyo ang actual stresses per column. Maka-proceed ka on solving per cutting section sa ilang hinges. Then you can reach to an answer of your reaction. I think that's the end of the slide. Cantilever lang may discuss for today. Any question ba, class, regarding cantilever? I know na ano lang na siya review because ginabalik-balik na may discuss good ang solving for forces. Diba? So, kana lang for today. Any question? Any question? Okay na? Over the height, including the flat or made up so that the formula today was that will be my discussion. That will be now for today. Per floor. So, and share minus mahatag ko og activity later tonight times WX times HX over sila niya. So, next week mo rin siya. So, where W is in